Welcome to the DIY Honda Garage channel. This presentation focuses on the diagnostic trouble code DTC P0335, which indicates a no-signal condition from the crankshaft position CKP sensor in the Honda Accord models from 2012 to 2017. The CKP sensor plays a crucial role in the vehicle's engine management system by detecting the injection and ignition timing for each cylinder, as well as the engine speed. It consists of a rotor and a semiconductor that measures the rotor's position. When the engine operates, the rotor turns, changing the magnetic flux in the semiconductor. This change generates pulsing signals that the powertrain control module, PCM, interprets. If these signals are not detected, the PCM identifies a malfunction, triggering the P0335 DTC. Understanding this error is essential for effective troubleshooting and repair. In conclusion, DTC P0335 is a critical error indicating a problem with the crankshaft position CKP sensor's ability to provide signals to the powertrain control module. The CKP sensor is essential for the proper operation of the engine, affecting injection timing and engine speed. A variety of causes can trigger this DTC, ranging from sensor failure to wiring issues. Troubleshooting requires a systematic approach to isolate and address specific problems. Regular maintenance can help mitigate issues surrounding the CKP sensor and improve overall vehicular reliability. By understanding the intricacies of this DTC, mechanics can efficiently diagnose and repair affected Honda Accord models. The crankshaft position CKP sensor, which is at fault when DTC P0335 is present, is responsible for detecting the timing of fuel injection and ignition events for each cylinder. This sensor is typically located near the engine's crankshaft, allowing it to monitor the position of the crankshaft effectively. The CKP sensor consists of two main components: a rotor that spins with the engine and a semiconductor. The rotor's movement alters the magnetic field within the semiconductor, resulting in pulsing signals sent to the powertrain control module, PCM. These signals tell the PCM about the engine's speed and timing. If the CKP sensor fails to deliver these signals, the PCM identifies the issue and stores the DTC, indicating that further diagnostics are necessary. Several potential causes can lead to the activation of DTC P0335. Firstly, a failure of the CKP sensor itself is a primary suspect. If the sensor is defective, it will not generate the necessary signals. Another cause might include an open circuit in the CKP sensor's CRKN line, which prevents signal transmission to the PCM. Additionally, if the CRKN line is shorted to ground, this can disrupt signal flow as well. Power supply issues, such as an open line in the CKP sensor's power source, may also prevent its operation. Ground line issues can similarly affect the sensor's functionality. Lastly, an internal malfunction within the PCM itself can contribute to the problem, complicating the diagnosis and repair process. When experiencing DTC P0335, several symptoms may manifest in the vehicle's operation. One of the most apparent signs is that the engine may fail to start altogether, leaving the driver unable to operate the vehicle. If the engine does start, it may exhibit poor performance, characterized by sluggish acceleration or misfires, as the ECU struggles to manage timing without proper input from the CKP sensor. Another clear symptom is the illumination of the malfunction indicator light, MIL, on the dashboard, a visual cue indicating that a diagnostic issue has been detected. Lastly, drivers may notice erratic engine speed, where the engine RPM fluctuates unpredictably, leading to an unstable driving experience. The first troubleshooting step for DTC P0335 involves verifying the functionality of the CKP sensor. Utilizing a multimeter, you should measure the resistance across the CKP sensor terminals. This provides crucial information about the sensor's condition and ensures that it functions correctly. Typically, if the resistance readings fall outside specified values, it indicates a faulty CKP sensor that needs replacement. Additionally, it is vital to ensure that the sensor connections are secure and free of corrosion. If the CKP sensor appears to be functioning properly, we must proceed to evaluate the wiring and connectors associated with the sensor. After verifying the CKP sensor's functionality, the next step in troubleshooting DTC P0335 is to inspect the wiring and connectors associated with the sensor. It is essential to check for any visible signs of damage, such as frayed wires or corrosion at the connector pins. Both an open circuit and short circuits can prevent the CKP sensor from delivering signals to the PCM, thereby triggering the DTC. If any damage is noticed, repairs should be made promptly to restore proper connectivity. After performing repairs, recheck the sensor's operation to ensure that the problem has been resolved. If wiring issues are not present, but the DTC persists, it may necessitate further diagnosis of the PCM. The next crucial step involves testing the CKP sensor's power supply to ensure it receives adequate voltage and current necessary for operation. Using a multimeter, check the voltage readings at the CKP sensor. The supply should typically reflect 5 volts or 12 volts, depending on the circuit design. If no power is detected, it indicates an open circuit that needs to be traced back to the PCM or the power relay. If the CKP sensor is receiving insufficient voltage or has fluctuating power, it may require replacement. Be sure to rectify any identified issues in the power supply line prior to concluding the diagnosis at this stage. After addressing all identified issues related to DTC P0335, the next vital step is to carry out a final repair verification. Begin by clearing the DTC from the PCM using a diagnostic scan tool, allowing the system to reset its monitoring. Once cleared, retest the vehicle, start the engine, and allow it to idle. Monitor the engine's performance and closely watch for the recurrence of the DTC or the illumination of the malfunction indicator light. MIL. Confirm that the engine operates smoothly without erratic speed or misfires. If everything checks out and no issues arise, the repair can be deemed successful. It's crucial to ensure all systems are functioning correctly before concluding the diagnostic process. To prevent encountering DTC P0335 in the future, implementing regular preventive maintenance is key. Begin by routinely checking the CKP sensor wiring and connectors. Ensure they remain secure and free from corrosion. Given that environmental factors can lead to deterioration, periodic visual inspections can help catch issues before they become significant. It is also beneficial to monitor the health of the electrical system as a whole. Poor electrical connections elsewhere can affect sensor functionality, so keep all related components in sound condition. Establishing a regular maintenance schedule can significantly enhance vehicle reliability and reduce the chances of unexpected breakdowns. Please like and subscribe to the channel. See you next time.